Fritz Haber won the Nobel Prize in Chemistry in 1918.
Haber was born on December 9, 1868 in Breslau, Prussia. This area is now known as Wrocław, Poland. In his youth, he went to school at the St. Elizabeth Classical School at Breslau.
In 1886, Haber went to college to study chemistry at the University of Heidelberg under Robert Bunsen, who is now famous for the invention of the Bunsen burner. Later, Haber went to the University of Berlin to study under A.W. Hoffmann and the Technical School at Charlottenburg to study under Karl Liebermann. Both Hoffmann and Liebermann were also highly regarded chemists at this time period.
In 1894, Haber was offered an assistantship at Karlsruhe University by the professor of chemical technology there, Hans Bundt. In 1896, he qualified as a private docent with a thesis on his experimental studies of the decomposition and combustion of hydrocarbons. This means that he was qualified to teach PhD students. In 1906, Haber was appointed professor of physical chemistry and electrochemistry and director of the institute established at Karlsruhe to study these subjects. He stayed there until 1911.
During his time at Karlsruhe University, Haber published a book on electrochemistry. He also is known for the Karlsruhe experiments on electrolysis of solid salts and for inventing the glass electrode for determining the acidity of a liquid. Haber also did the first experimental investigation of potential differences that occur between solid electrolytes and their aqueous solutions.
In 1911, Haber was appointed to become the director at Kaiser Wilhelm Institute for Physical Chemistry and Electrochemistry in Berlin-Dahlem, which was later renamed after Haber. He remained the director there until 1933.
Haber is well known or maybe infamous for his supervision of the German poison gas program during World War I. When the World War I started, Haber was asked to be a consultant to the German War Office and organize gas attacks and defenses against them. He became vigorously involved in the production of protective chemical devices for troops. He also developed many of the chemical poisons that were used as weapons.
Haber also studied the effects of gas on humans. He found that exposure to a low concentration of a poisonous gas for a long time often had the same effect, death, as exposure to a high concentration for a short time. He formulated a simple mathematical relationship between the gas concentration and necessary exposure time. This relationship became known as Haber's rule.
Haber's wife, Clara Immerwahr, was the first woman to receive a doctorate from Breslau University. She was also a chemist who strongly opposed his work on poisonous gas, and she publicly pleaded with him to end his experiments in chemical warfare. She ultimately committed suicide with his service revolver in their home garden to protest chemical weapons use. Her story was made into a TV movie in Austria in 2014.
Haber was awarded the Nobel Prize in Chemistry in 1918 for his process to synthesize ammonia from its elements, nitrogen and hydrogen. Because of some technical rules related to the requirements of the Nobel Prize, Haber was actually awarded his prize in 1919.
The process for which Haber won the Nobel Prize has become known as the Haber process. The Haber process combines nitrogen from the air with hydrogen derived mainly from natural gas, methane, to convert them into ammonia. This reaction is reversible and the production of ammonia is exothermic.
The process begins by mixing nitrogen from the air with hydrogen from natural gas in a volume ratio of 1 to 3. The reaction is generally carried out in under 200 atm and between about 400 and 450 degrees Celsius. An iron-based catalyst is used to speed up the reaction. With recycling, the process has a yield of 97%.
From 1920 until 1926, Haber experimented on the recovery of gold from seawater. The goal of his idea being to enable Germany to meet her war reparations. He attempted to gather commercially valuable amounts of gold from seawater by chemical extraction, but he didn't succeed due to the low concentrations of dissolved gold in seawater. Haber's failure was ascribed to incorrect estimations of gold abundance in the ocean based on poor analytical methods available. His work later paved the way for extraction of bromine from the ocean using similar techniques.
In 1933, the Nazis instituted race laws against the Jewish people that would have compelled Haber to force nearly all of his staff to resign. Rather than agree to these demands, Haber resigned himself. He left Germany to teach at Cambridge in England.
Haber remained for a while in England. He was suffering from a heart disease and died on January 29, 1934, on his way from England to a convalesce in Switzerland. They said that his spirit was broken by the rejection from Germany that he had served so well. After his death and the fall of Nazi Germany, the German people once again recognized his contribution to the country. He received other posthumous honors as well.